Good afternoon, and welcome to this edition of the Embedded Executive Podcast. I am Rich Nass. I am the Executive Vice President of Open Systems Media. I lead the embedded IoT teams for embedded computing design. This week, my guest is Adam White, who serves as the president of Infineon's Power and Sensor Systems division. How you doing, Adam?
Very good. Thanks for having me, Rich.
My pleasure. So I see a little bit of a disconnect, I'll say. We wanted this discussion to be around AI, but you're responsible for sensors and power. What's the relationship there between sensors and power and AI?
Yeah, fantastic. So look, from the power perspective, we go from the grid to the core. And using the latest semiconductor solutions, we can then, of course, proudly power AI. And then on the sensor side, for example, on the edge AI, we can actually offer silicon microphones at a very high signal to noise ratio, which can be used to improve the quality of the sound. So that's why we are here today talking about powering AI, but of course in sensors we offer the silicon microphones.
Okay, so the way I perceive that is that you're driving some of these processors that are doing the AI, and just coming back from Computex, where they're talking about pretty much AI on everything, but the processors to drive this are very power hungry. How much of a problem will that be causing? And I'm assuming you have a solution to that problem.
Yeah, absolutely. So look, the amount of course, compute power is exponentially going up now, Rich. If you look at now all the use cases, you now look at the amount of structured data that is being created. You then need, of course, software to train the ability to do large language models. And then, of course, that increases the compute power. Now, here we talk about the power in one, of course, powering the GPU or the XPU, whatever it may be. But on top of that, you need to power the actual data center racks as well. And traditionally, the racks were around, say, 20 to 30 kilowatts. And in the latest generations of the GPUs, going from the traditional CPU architecture, you can now go up to greater than 100 kilowatts per rack. So here, what we're looking to do is, of course, support energy efficiency in the PSUs for the actual power supplies going into the rack, but we also be supporting the power supplies for the GPUs as well. And I must state, in every data center, you don't just have the GPUs, you have corresponding CPUs and, of course, the power requirements for those as well.
So is the solution to provide them better and more efficient power, or to get them to consume less power?
Yeah, I would say both. Because ultimately, when you're moving into this amount of power required for data centers, think about it. You know, back in a report from the International Energy Agency, since 2010, about 2% of the world's energy was actually powering data centers. That is expected to go up to anywhere from the scenarios of 3.5% of the world's energy to around 7%. And 7%, just to equate that to your listeners, is around the amount of energy that India consumes. So first things first, we want to work with these GPU and data center hyperscalers to support more energy efficiency. And then on top of that, that will also reduce the carbon footprint that supports decarbonization.
Okay, so I would expect the leaders to do something about this, and I'm looking at you, Infineon, you're one of the leaders. What are you going to do about this?
So again, you know, the industry recognizes that if you actually use the latest power semiconductor solutions out there today, you can actually reduce about 48 terawatts of hours of electricity that can be saved per year. And if we actually do that and the industry embraces the latest solutions, actually that is as much electricity as Portugal consumes in a year. So that's why we're very motivated in supporting this journey. We're at the beginning of the journey. The adoption of AI is transformational. If you go back to look at how long it took for the internet to adopt, you look at now how many users of AI, it is of course exponentially rising. And that's where there's a great opportunity to support leading edge power semiconductors and ultimately supporting the decarbonization journey.
Would you go down a level? What, more specifically, what are you guys doing?
Yeah, so let's go through a typical data center. So for example, in the data center, I was alluding to the, first of all, in powering these racks. And again, the racks are now going up to greater than 100 kilowatts. So we now offer now solutions for PSUs going from 3.3 kilowatt all the way to 12 kilowatts. Now, what's pretty unique about that, here in our case, we're actually supporting three technologies. We're doing this with silicon, we're doing this with silicon carbide, as well as gallium nitride to bring in the maximum efficiency. Then you go to the next level of, okay, you're powering the data center, now rack itself. So now what about the blades, meaning the GPU accelerator cards, the motherboards? And this is where we are using the latest power semiconductors to support, of course, more energy efficiency. You go from a IBC, an intermediate bus converter, and then from there you can then effectively move from 54, 48 volts down to 12, down to core. So again, we offer solutions in those areas. And then, of course, then if you're powering the GPU, there's different ways of doing this. You can do this laterally, where you put the solution next to the GPU, or you can do vertical power solutions, which is an incredible innovation that provides even more efficiency under the GPUs. And just high level, Rich, look, think about it. A CPU uses around 300 to say 400 watts of energy, and now the new GPUs are going up to anywhere between 700, 1,000 watts and beyond. So this area is a key area for our focus. And not you know, last but not least, but we also support the areas of protection ICs, the hot swapping. Those areas are, of course, very important for us as well to offer the latest solutions.
So let's make believe we're having this discussion 18 months from now. Throw some of those same things out there. How much power is being consumed, and what are you guys offering today, 18 months from now, to solve those problems?
Yeah, so again, we're working with the who's who of the customer base, the GPU vendors, right the way through to the hyperscalers. And we're really understanding their requirements on power levels. So again, when I was coming into the industry, the switch mode power supplies were 800 watts, 1 kilowatts. And now, as I mentioned, we just recently announced we're going up to 12 kilowatts. Making sure we hit the power density as one example. And the other area is the GPUs get a lot more power hungry, and they go up the wattage per GPUs. The amount of current is in the thousands of amps now, right, or over 1,000 amps. And here, this is another area that we need to come together with the industry, working to make sure that we provide best-in-class solutions to help with the overall efficiency as well as the density, because size is also very important, because you want to maximize the compute power per data center, because these data centers are not cheap, and of course they're very expensive to run, for example, for air conditioning, cooling, later generations for liquid cooling and beyond. And just to give you an example, of course, if we support the reduction of heat, meaning more power efficiency. Today, around 40% of the energy in the data center is only going there for cooling of the solutions, meaning waste of efficiency, and that's something that we can definitely support moving forward.
Good stuff. So if I'm a system designer, you're telling me I have nothing to worry about, right?
I would say that honestly, this is an exponential explosion of amazing innovation, right? And every meeting that we have with the who's who in the industry, the lead customers, their engineers are surprising us with where they wish to go with this AI trajectory. So, of course, it's keeping us on the toes. And hey, at the end of the day, these are great problems to solve, but we feel responsible that we should be solving these problems, because ultimately there is a consequence to this, that you are burning more electricity. So that's something that we need to, of course, keep at the forefront of our focus. But I'm very confident we can partner up and support that journey.
Awesome. Thank you very much, Adam. This was good stuff. That was Adam White. He is the president of the Power and Sensor System Division at Infineon, and I am Rich Nass with Open Systems Media.